We're continuing on the 6-2 notes, which is differential equations, focusing on growth and decay. And we've got a problem like this where it says the rate of change p with respect to t. Now, the way we write that, the rate of change p with respect to t. So when we say the rate of change, that goes in the numerator, with respect to goes in the denominator. And it's proportional. That means there's some proportionality constant that we usually call k. And we're talking about a direct proportion here. Now when I multiply it, I get 10 minus t. Now sometimes we forget to write the k. Well, when we're doing that, we're actually saying k is 1. So we want to make sure we include the k here, and what's going to happen is our answer for p will have k in it. Alright, the next thing I'm going to do is, since everything over here is in terms of t, I can go through and multiply both sides by dt. And there isn't anything I have to bring over to the dp side. And so that means dp is equal to 10k minus kt dt. And I'm going to integrate that. And over here I'm going to get p, and I'm going to have 10kp minus 1/2 k t squared plus c. And that's my answer of p. It has all those particular, the two constants, k and c. Alright, let's take a look at another problem. And this particular problem is, it's based on exponential growth and decay. And I'm going to have something that looks like y equals c e to the kt power. This is our classical growth decay exponential function. And has two constants in here. It has a c, and c is our initial constant. It is the value that we have at time 0. K is our constant of proportionality. And it has some, if k is greater than 0, we have growth. If k is negative, it's less than 0, we have decay. Alright, so here's the problem. I have, at time 0, 50 flies. Two days later, I have 150 flies. At time, when I have, on these are days, I suppose, I better say, at 2 days. And at 5 days, how many flies will I have? And then you are told that this is an exponential function in that particular classical form. Well, the first thing we can see is that right away my initial value right here at time 0 is 50, so c is going to be 50. And the reason that is if I put 0 in for t, k times 0 would be 0, e to the 0 would be 1, and I'd be left with 50. So now I just need to figure out my k, and that's, so I used this particular value. I now move down the line, I'm going to use this particular value, and I have 150 equals 50 e to the k times 2 power. Well, that means 3, because if I divide both sides by 50, I get 3e to the, I'm going to write this as 2k. So to get access to that exponent, what I'm going to do, and I'm going to write it up here, I'm going to take the natural log of both sides. Because I'm going to have the natural log of 3, I can simply, or natural log of e, I can simply say of 2k, because the natural log of e is 1. So the natural log of 3 divided by 2 is equal to k. Alright, I'll go to my calculator and figure out what that is. Clear the screen here so I don't have all this stuff. Natural log of 2 divided by, excuse me, that was wrong. Let me do that again. Let me clear that. I want the natural log of 3 divided by 2. And I get 0.549 about. So down here I'm going to have 0.549 equal to k. So now that means my equation is y equals 50 e to the, and what do I have, 5 days times 0.549. And so y is going to be, and I'm going to go back to my calculator here, here, then I'm going to have shift, oops, let me clear that, let me have 50, and I'll go shift natural log to the 5 times, and it's my answer that I just computed, this 0.549, shift that, and I'm going to have about 779 flies.